so this is the chemistry section 12.3 lesson video part 2. So if you've already watched part 1, we learned how to do limiting reagents problems, and so now we're going to focus on percent yield. Again, please do not watch this video if you don't understand 12.2 yet, the basic 3-step stoichiometry problem, because this is just going to be confusing. Alright, so the theoretical yield is the maximum amount of products that can be formed from a given amount of reactants. So it is a calculated amount. So when we do a reaction, we can calculate how much product we're going to get. When we do that, that's called the theoretical yield. That is the most possible that you can get. However, a lot of times in the lab, we don't get the full amount. So the actual yield is the amount of product that is produced in the lab. So, for example, when you take a test, the maximum you can make is 100, so that's your theoretical yield. But in reality, you may only make a 78. That would be your actual yield. Now, on a test, we know the maximum you can make is always 100. We're just going to exclude bonus points. All right, it's always 100. So there's nothing to calculate. We know you can make up to 100. We just have to figure out what you actually make. Well, in a reaction, how much you could make could be any number. So we actually have to figure out what the maximum you could make is. And then the actual lets us figure out, how well you did. A percent yield is kind of like your grade on how well you did a lab. Now sometimes you could do everything perfectly and a reaction just does not have a high percent yield. It's just a reaction that's really hard to make it go all the way through 100%. So the percent yield is the ratio of the actual yield to the theoretical yield times 100. Okay, so I guess I'll just throw that over here. I'm running out of room over here. So percent yield is actual over theoretical times 100. So since the theoretical yield is the maximum amount of product, the percent yield can never be over 100%. You cannot make more than possible. So if you ever solve one of these problems and get over 100%, you did something wrong. Most likely you mixed these two numbers up, or you calculated your theoretical yield wrong. All right, so just go back and look at your math. So let's look at one of these together. So it says, what is the percent yield if 13.1 grams of CaO is actually produced, I'm going to underline actually here for a second, when 24.8 grams of CaCO3 is heated. Now, it may look a little different because there's no question mark, because technically it was asking for a percent yield. Like, what's the percent yield? So it's like, well, where are we starting and where are we going to? Like, are we going to CO2? The answer is no. Okay, so it says, what is the percent yield if this many grams of Ca is actually produced? So what they did was they gave you the actual yield. What are we missing to get percent yield? We're missing the theoretical yield. So this is where people have trouble setting this type up. So what you're going to do is you're going to go from here and go to the same substance to try to figure out what the theoretical is. Okay, because what's happened is they're saying we went in the lab, we reacted this much, and we got 13.1 grams. We don't know how much we should have gotten. Okay, so for percent yield, the biggest struggle I see for people is figuring out where to start, how to set the problem up. Okay, so they're going to give us an actual, but we need to figure out the theoretical of that same substance. All right, and we do that through a basic 3-step stoichiometry problem. Just the basic 3 steps that we all know and love. So we start with what we know. So we know that we reacted 24.8 grams of CaCO3. So don't worry about any of this right now. Let's just focus on our 3 steps. Step 1 is convert to moles. I gave you grams, so you're going to do molar mass. So you add up CaCO3 off the periodic table. So it's 40 plus 12 plus 16 times 3, and that gives us 100. So I follow my golden rule and put grams of CaCO3 on bottom, and it's 100 like we just added up. And remember, molar mass always equals 1 mole. So my grams of CaCO3 cancel. All right, so step 2 is I do my mole ratio. So 1 mole of my reactant makes 1 mole of my product. So I follow my golden rule and put moles of CaCO3 on bottom, and it's 1 mole because that's the coefficient, it makes 1 mole of my product. So my moles of CaCO3 cancel, and then I move on to step 3, convert to unit asked for. In this case, they didn't technically ask for a unit because they asked for percent yield, which has the unit of percent, but because they gave me the actual in grams, I want to calculate my theoretical in grams also. Okay, so we're trying to get to grams, so I know that means I need to use molar mass. So this time I'm doing molar mass for CaO. So Ca is 40, O is 16. That gives me something that looks like 56. Alright, so I follow my golden rule and put mole of CaO on bottom. Remember, molar mass always equals 1 mole. And my 56 grams on top. So my moles of CaO cancel, and then I multiply across the top and divide across the bottom. And when I do that, I get 13.9 grams of CaO. So this right here is my theoretical. Alright, so what's happened is, in the lab, we heated this, and we got 13.1 grams of product. If our reaction had worked 100%, we should have gotten 13.9 grams of product. So see, we got a little bit less. So now we have our actual, and now we have our theoretical, so now we can do percent yield. And notice the theoretical, we had to calculate that number. Alright, so then we follow our formula that I have written right here. Percent yield is actual over theoretical times 100. Well, our actual was given to us. It's 13.1 grams. Unless I'm going to have you stop and do a lab in the middle of a test or quiz to get the actual, I'm going to have to tell you what the actual is. Alright, so the actual is 13.1 grams. That's what was created in the lab. But we should have gotten our theoretical, which is 13.9 grams, and then times 100. So if you notice, your grams cancel. When you solve, you should get 94.2. And because your grams cancel, your unit is percent. Remember, I'm super picky about units. You don't have to put the substance here, but you can if you want to. Okay, so you could put 94.2% CaO if you want to. All right, so that's a pretty good percent yield, though. You know, that's an A. All right, so that's how you do percent yield. So let's look at a couple more. So see, these aren't that bad. They're shorter than doing a limiting reagent problem. All right, so let's look at our top one together. So it says if 50 grams of silicon dioxide, so silicon dioxide SiO2, is heated with an excess of carbon, 27.9 grams of silicon carbide is produced. What is the percent yield? All right, so here we go. This one, it says we heated 50 grams of silicon dioxide and we got 27.8 grams of silicon carbide. So that means this right here is my actual. That's how much was actually produced. So remember, what I do is I start with my reactant and I go to the same product to get my theoretical. Now, sometimes people want to say, well, how do I know I don't go this way? Well, a yield has to be a product. Think of it this way. The arrow is called the yield sign, so it points towards what you yield, all right, or produce. So you can't say that this is an actual yield. That's what you're starting with. All right, so we're going to do a basic 3-step stoichiometry problem. So I start with what I know, and that is 50 grams of silicon dioxide. And so I go to step 1, convert to moles. Well, since I have grams, I'm going to do molar mass. So I add up SiO2 off the periodic table. Si is 28, O is 16 times 2. And so when I do that, I get 60 grams. So I follow my golden rule and put grams of SiO2 on bottom, and I put 60 because that's what we just added up. And molar mass always equals 1 mole. So I do 1 mole of SiO2 on top. So my grams of SiO2 cancel. Then I move on to step 2, which is my mole ratio. So 1 mole of my reactant makes 1 mole of my product. So I follow my golden rule and put moles of SiO2 on bottom, and it happens to be 1, and that makes 1 mole of my product. So my moles of SiO2 cancel. And so then the third step is to convert to unit asked for. So again, they gave me the actual yield in grams, so I will do my theoretical yield in grams. So if I'm doing grams, I'm going to figure out molar mass. So Si is 28 and carbon is 12 on the periodic table. So that gives me 40 grams. I follow my golden rule and I put mole of SiC on bottom. Molar mass always equals 1 mole. And that equals my 40 grams on top. So my moles of SiC cancel. So I multiply across the top, divide across the bottom. And so for this one, I get 33.3 grams of SiC. Now because I calculated this amount, that means it is my theoretical. Okay, so now I have that we actually made 27.9 grams. If we were perfect, in a perfect world, we should have made 33.3 grams. Alright, so last step is to follow my formula. Percent yields actual over theoretical times 100. So my actual is 27.9 grams over my theoretical, which was 33.3 grams times 100. Grams will cancel, and so I get 83.8, and my unit is percent. Okay, so not quite as good of yield as we got in the previous problem. Alright, so like I said, for percent yield, the hardest thing for people to do is set it up. Because they have trouble. A lot of people, they want to take this easy way out and they'll just say, oh, well, this is my actual, this is my theoretical, and they don't even do a stoichiometry problem. Y'all, it's stoichiometry. You're going to have to do a stoichiometry problem somewhere in there. If you're solving any problem in this chapter and you're not doing something that looks like this, you're doing it wrong. Alright, so now I want you to try the next one. Alright? Oh, I don't need to erase this shit. So I hope you at least set it up. So it says, when 15 grams of Sb2S3 reacts with an excess of iron, 9.84 grams of Sb is produced. What is the percent yield of the reaction? Alright, so we're starting with 15 grams. We made this much. So this is my actual. So remember, I'm going to go from here to the same product to get my theoretical. Alright, so pause the video, try this one, and I'll assume you've done that, so let's knock it out. So I start with what I know, and that is that I'm starting with 15 grams of Sb2S3. So I follow my stoichiometry problem. Convert to moles. Since I have grams, I'm going to use molar mass. So I need to add up Sb2S3 off the periodic table. So Sb is 122 times 2. S is 32 times 3. And so all of that adds up to be 340 grams. So I follow my golden rule and I put grams of Sb2S3 on bottom. So I'm going to put my 340 down there. And remember, molar mass always equals 1 mole. So my grams cancel. And then I move on to step 2, which is mole ratio. So in this case, 1 mole of my reactant makes 2 moles of my product. So I follow my golden rule. My moles of Sb2S3 goes on bottom. How many? 1, because that's the coefficient. And that equals 2 moles of my product. So my moles of Sb2S3 cancel, and so then I move on to step 3, convert to unit asked for. So again, my actual is given to me in grams, so I'm going to do my theoretical in grams. I'm going to use molar mass. So Sb is 122 on the periodic table. So I follow my golden rule and put mole of Sb on bottom. And molar mass always equals 1 mole. Oops, sorry, I pointed at the wrong one. I mean, it's still a 1 mole. Alright, and that equals 122 grams from the periodic table. Remember, molar mass just comes from the periodic table. So my moles of Sb cancel. So next, I multiply across the top and divide across the bottom, and so I end up getting 10.76 grams of Sb. So this is my theoretical. So we made 9.84 grams. We should have made 10.76 grams in a perfect world. So last step is to calculate percent yield. So percent yield is my actual, which is my 9.84 grams, divided by my theoretical, which is 10.76 grams times 100. And so then I end up with 91.4%. And that's it. Alright, so really you're just doing a 3-step problem and then just plugging into a formula. Like I said, the hardest part is figuring out how to set it up because it's really weird to go to something that you already know a number for. But remember, you're trying to figure out what you should have made. All right, so let's move on. I think all we have left is our section assessment. All right. So the first one says, oh wait, we don't have section assessment. This is like our challenging problem. All right, so this one, if you're feeling confident, if you can do this problem, you can literally do anything that I give you out of this chapter. All right, so it says if 15 grams of nitrogen reacts with 15 grams of hydrogen, 10.5 grams of ammonia is produced. What is the percent yield of the reaction? Hint, this is a limiting reagent and a percent yield problem. All right, so if you're feeling super confident, like you're the most awesome person that you've ever met in your life, go ahead and pause the video and try it now. If you're feeling a little less confident, I'm going to at least set it up for you. Okay, so it says we have 15 grams of nitrogen, and it reacts with 15 grams of hydrogen, and 10.5 grams of ammonia is produced. What is the percent yield? So, if you're feeling that slightly less confident, I set it up for you a little bit. Now you pause it and try it. Now if you're still feeling a little bit less confident, I'm just going to kind of tell you what to do and then you can try it. Alright, so what it's saying is we have these two starting amounts. That's how I know it's a limiting reagent problem, because I have two starting amounts. Now it told me we produced this much, so I know this is my actual. I've got to figure out what the theoretical is, but since I have the two starting amounts, remember you got to do two 3-step problems. So what you'll do is go from 15 grams of this to here, 15 grams of this to here, and then the lowest equals your theoretical, okay? So now you can try it. Now if you're feeling totally unconfident in yourself, then just watch me do it, but I want you to at least try it. Alright, so I'll assume that all of my confident people have tried it at this point, and let's go ahead and knock this one out. Oh my gosh, if you got this right though, you are awesome. Alright, so what I'm going to do is I'm going to start with my nitrogen and figure out in theory how much ammonia I should have made. Alright, so I start with my 15 grams. And so my first step is convert to moles. Since I have grams, I'm going to use molar mass. Now instead of me saying where I'm getting molar mass from every time, I'm just getting it from the periodic table. Okay, so when I add up my grams for N2, I get 28, and molar mass always equals 1 mole. So my grams cancel. Alright, step 2 is mole ratio. 1 mole of N2 makes 2 moles of NH3. I put moles of N2 on bottom by following my golden rule, and that's 1. And that makes 2 moles of NH3. So my moles of N2 cancel. Step 3, convert to unit asked for. I'm going to grams because my actual is in grams, but this time I'm doing molar mass for NH3. When I add that up, I get 17 grams. I'm following the golden rule, so I put moles of NH3 on bottom. Well, molar mass always equals 1. And I put my 17 grams that I added up from the periodic table on top. I multiply across the top and divide across the bottom, and I get 18.21 grams of NH3. Now the problem is I don't know if that's my theoretical yet because we have two different starting amounts. Okay, so remember we have to figure out which one's the lowest before we know which one's the theoretical. That's what makes this problem so hard. Alright, so now I'm going to start with my hydrogen and figure out how much product I should make. So I have 15 grams of hydrogen, which is H2. Step 1 is convert to moles. Since I have grams, I'm going to use molar mass. H2 has a molar mass of 2. I follow my golden rule and put my grams on bottom, which is 2 grams. Molar mass always equals 1 mole. So my grams cancel. Step 2 is mole ratio. So we are going from hydrogen, which is 3 moles, to ammonia, which is 2 moles. I follow my golden rule and put moles of hydrogen on bottom. How many? 3, because I pull from the coefficient. 3 moles of hydrogen makes 2 moles of ammonia. So see how much easier it gets like as you go through them over and over again, you see the pattern? Alright, and just imagine if you were doing it by yourself. You could go even faster because you're not having to listen to me explain everything. All right, remember, the saving grace on these is we know the last step is the same. That's the only shortcut that I can give you. So my moles of NH3 cancel, and so when I solve this one, I get 85 grams. So remember, we always go with the lowest one, but that's not my answer, that is my theoretical. So we made 10.5 grams, we should have made 18.21 grams. Now if we had more N2, we could have made all the way up to 85 grams, but we didn't. Okay, so this is how much I should have made, because once I make this much, we're out of N2. Alright, so now I have my actual and my theoretical, so then I just plug in. So my actual was 10.5 grams. In theory, we should have made 18.21 grams times 100. Those grams cancel, and so, drum roll, let's see who got it right. You should have gotten 57.7% because your grams cancel. So, oh my gosh, I wish you were in class so I could see you raise your hand if you got it right. You'll just have to let me know if you got it right. So the reason I say if you can do this one, you can do any problem in this chapter is it includes mole ratio. That was the first type of problem we learned. It includes the 3-step stoichiometry problem. That was the second type we learned. It includes a limiting reagent problem. That was the third type we learned. And it includes percent yield. That's the fourth type. So this includes any type of question I could ask you in this whole chapter. All right, so hopefully if you didn't get it right, you at least, got some of it right, which is still great. Okay, you just started learning this. You don't become an expert overnight. All right, so now section assessment. So in a chemical reaction, how does an insufficient quantity of a reactant affect the amount of product? Well, an insufficient quantity is the limiting reagent. So I always call it LR. So LR determines the amount of product produced. Because remember, once you run out of the limiting reagent, the reaction stops, and so no more product is produced. It's not like making a sandwich. You can't make the product without something. All right, so last problem. What is, and so you may want to pause it and try this one on your own. This is just a normal percent yield problem. What is the percent yield if 4.65 grams of copper is produced when 1.87 grams of aluminum reacts with an excess of copper 2 sulfate? All right, so remember, they told me how much was produced, so this is my actual. So what I need to do is go from my reactant to my product, the same product, to get how much in theory, our theoretical, our maximum amount, so I can plug into the formula. Okay, so we start with what we're given, which is 1.87 grams of aluminum. So step 1 is convert to moles. When I have grams, I use molar mass. So that is 27 grams, and I put grams on bottom because of my golden rule, and molar mass always equals 1 mole. So my grams of aluminum cancel. Step 2 is mole ratio. 2 moles of aluminum produces 3 moles of copper. So I follow my golden rule and put moles of aluminum on bottom. I look at my coefficient and put 2, and that makes 3 moles of copper. So my moles of aluminum cancel. All right, last step is convert to unit asked for. Well, since my actual is in grams, I'm going to make my theoretical in grams. So I use molar mass again. For copper, it's about 64 grams, but I'm going to follow my golden rule and put mole of copper on bottom. Molar mass always equals 1 mole, and put my 64 grams on top. So my moles of copper cancel. I multiply across the top, divide across the bottom, and I get 6.65 grams of copper. So because I calculated this, this is my theoretical. So we made 4.65. We were supposed to make 6.65 in a perfect world. So percent yield is actual, which is 4.65, over theoretical, which is 6.65 grams, times 100. Those grams cancel. And so once I solve, I get about 70%. I get 69.9%. Remember, unit is percent for percent yield. All right, so that is the end of the stoichiometry chapter for chapter 12. So keep in mind, the whole basis is that 3-step problem. So make sure that you understand how to follow the steps. Remember, if you're using the mole map, that's fine, but you're going to have to get to where you don't need it because you can't use the mole map during tests or quizzes. All right, you got to be able to just follow the steps in your mind. All right, so hopefully you found stoichiometry not too terrible. I joke that it's my favorite because it really is, but I know that a lot of y'all really struggle with it. So hopefully it wasn't too bad, and if you have any questions, just let me know.